Hello class, today we're going to look at systems of equations, and the problem that we're showing here is from 4.1 in your study plan. I'm going to show you how to solve this system using graphing, and then we're going to also solve it using elimination and solve it using substitution. So we're going to solve it with the three different methods we're learning this chapter, and you're going to see how we can get the same answer. Okay, so let's start off by graphing these. So when we're solving a system using graphing, the idea is to graph each line, and then we want to determine where they intersect. That point where they intersect, if they do intersect, is going to be our solution. Okay, so let's go ahead and first start off by, if we want to graph these, I'm going to put them into y equals mx plus b. Remember, there's a couple different options for graphing, so if you're using the intercepts or a different option, you are welcome to use those as well. But I'm going to use y equals mx plus b. So I'm going to use two different colors. I'm going to start with this one, and we'll graph that one in blue. So the first thing you want to do is, everything's already moved over, it's solved for y. I'm just going to rearrange this so it's in the proper order. Notice my 2x is positive, so it's going to stay a positive 2x. This is a positive 3, so we're going to keep positive 3 there. So let's go ahead and graph this line. It's in the y equals mx plus b already. Remember, the b is our y-intercept, so that tells us where to start on the y-axis. So I'm going to go up 3. So 1, 2, 3. That's my first point. To find the second point, we use the slope, and the slope of my problem is 2 over 1. So that means rise 2, okay, that's positive, and right 1. Now, the idea with systems of equations, when you're graphing them, is you probably want to use a few more points than just 2. Math Excel only requires you to do 2, but as you're doing the work on your paper, you probably want to do a few more points. So remember that 2 over 1 is the same as negative 2 over negative 1. So just like I can go up 2 and right 1, I can also go down 2 and left 1. I have a little more room down here, so I'm going to keep on going down to left 1. And we can continue that process as long as we want. So you can see how I have a few more points than normal. Okay, so we go ahead and connect our dots. If you have a straight edge or something to use, like credit card works good, make sure that line stays straight. So that's our first line. Now we're going to go ahead and graph our second line. I'm going to pick a different color. We'll pick this one in red. So we have x plus y equals negative 6. To get it into the y equals mx plus b, I have this x here, so I'm going to go ahead and subtract it over, so minus x from both sides. That's going to give me y equals, again we want to worry about order since we're doing mx plus b, so I'm going to put the x term first and the minus 6 in the back. Those aren't like terms, we can actually subtract them together to get one term. And now this one is ready to use the slope-intercept form. So negative 6 tells me to go down 6. 2, 3, 4, 5, 6. And the slope, remember there's a 1 and a 1. So we have negative 1 over 1. So negative 1 means down 1 and right 1. So it's actually going off my graph a little bit. But remember, we can also have positive 1 over negative 1. Notice I just flipped the negative sign. Negative divided by a positive is a negative, and a positive divided by a negative is a negative. That's why I can use both of these. So this bottom one tells me up 1, left 1. So you can see how that's going towards the blue line. So up 1, left 1, up 1, left 1. And I want to keep doing this until I find that they cross or intersect. connect your dots. And we've graphed our two lines. Now what we're looking for is we're looking for the point where they intersect. That's going to be the solution. That's the point that makes both equations true. So I notice that we have a point here. So let's figure out where this is. From the origin it is left 3. So that's my x value. And then down 3. So that's my y value. So the solution to this system is at the point -3, -3. Now notice graphing works nicely when your graphs cross at a nice point where your numbers are integers. Now if our lines were to cross somewhere in the middle, it would be hard to estimate where that value was and get the exact answer. So that's when we would really want to focus on using one of the other methods like elimination or substitution. So let's go ahead and look at those methods and show you how you can find the same answer just using the other methods. So let's use substitution next. Now the substitution method is good to use when you have one equation that is set equal to x equal or y equal. So if you look at this problem, the first equation is set into y equals. The other one is not. This is a prime example of when I would use substitution instead of graphing. Let me go ahead and show you how this works. So substitution means we're taking a chunk. The 3 plus 2x is equal to y. So anywhere I see a y in my second equation, I can change it or substitute it for 3 plus 2x. So I'm going to drop that in to where y is. So the x stays the same, plus, we have a 1 in front. We don't have to write the 1 here, but if this was a 3, you would want the 3. So if you want to get in the habit of just writing the 1 there, just so you remind yourself that if there is a coefficient, we want to include it. So I'm changing y for 3 plus 2x, or substituting it. And this equals -6. Now notice all we have left is x variables. So we can solve this equation. Distribute the 1 in. It's not going to do anything, but if you had a number there other than 1, it would. So we have x plus 3 plus 2x equals -6. Combine like terms. So I have a 1x and a 2x. Those combine to give me 3x plus 3 equals -6. Subtract the 3. We get 3x equals -9. Divide by 3. And we get x equals -3. Now we feel like we're done. We feel like we have the answer. But remember, when we're finding the solution to a system of equations, we're trying to find a point where they cross. So this is half of the solution. It's our x value. Now to find the other solution, I'm going to take this x value, I'm going to plug it into either equation to find y. Well, if I'm looking for the y variable, I probably want to use the equation that says y equals. So that's the one I'm going to pick. You can use either equation. So we have y equals 3 plus 2x. So we're going to take this value of x and drop it in, and that should tell us what y equals. So y equals 3 plus 2 times -3. Remember, if I'm moving too fast, you can always pause and rewind. So we have y equals 3. Positive 2 times -3 is -6. And y equals -3. So again, we found the solution is at -3, -3. And we should be finding the same point. Doesn't matter which method we use. So that's substitution. Again, it's good to use when you have one of the equations y equals or one of them's x equals. You don't have to have that right off the start, but it's good to have that. That tells you that that's probably a good option to use. And the last option for us is elimination. And the idea of elimination is to line up the variables and try to add the two equations together so that one of the variables is eliminated. So I want my equation to look like the bottom one, where the x and the y are on the left side. So on this top one, the y equals 3 plus 2x, I need to move this x back to the left side. So I'm going to subtract 2x. And I want to try to line up the variables, so I want them in the same spot. So I get -2x plus y equals 3. So I've changed that first equation into this form. I want that x first, then the y, just like the second equation. So this is how elimination works. We're going to take the -2x plus y equals 3. That's the equation we just created. And we're going to put x plus y below it equals -6. Now the idea is for us to add these straight up and down so that one of the variables cancels out when we add them. Notice that if we add right now, -2x plus x, that would give me -x, so that wouldn't cancel out. 1y plus 1y would give me 2y. Okay, so I'm not ready to add them yet. So what we want to do is we want to create the same number in front, opposite signs. Doesn't matter which variable you pick. I notice that I have a -2 here, so that means I would need a +2 here if I wanted to use the x's to eliminate. So all I need to do is multiply by 2. I'm allowed to do that if I multiply all the terms. So I still have my first equation, -2x plus y equals 3. Distribute this in, and I get 2x plus 2y equals -12. Now notice that we have the same number opposite signs, so we're ready to add these two equations together. So I'm just going to add them straight up and down. -2x plus 2x is 0, so that's gone. 1y plus 2y is 3y. 3 minus 12 gives me -9. Now notice I only have one equation. Divide by 3, divide by 3, and we get y equals -3. Okay, so here's part of our answer. Remember, it feels like we're done, but we're not really done. This time we found the y variable first. So now that I have the y variable, I need to plug it in to find the x variable. Now neither of my equations are x equals, so that doesn't tell me which one to use. So I'm just going to plug it in. I'm going to pick the second one this time, just to show you something different. So we have x plus y equals -6. I'm going to take the -3, drop it in. That's going to give me x. Go ahead and erase that so we keep the same colors. So we have x plus a -3 equals -6. And go ahead and simplify. So x minus 3 equals -6. Add 3, add 3, and we get x equals -3. So I have -3 is the x value. Again, notice that we have the exact same solution. So those are the three methods: elimination, substitution, and graphing. All three should produce the same result. If you are getting fraction answers, then graphing is probably not your best option because you're going to have to estimate. So if you do start to see a fraction involved in your answer, you would want to switch to one of the other methods. But those are the three methods of solving a system of equation. Okay, let's go back to Math Excel and put in our answer for the graphing. So our first equation, y equals 3 plus 2x, that was our blue line. So we're going to come over here. I'm going to maximize this. I'm going to pick the line. My first point was at 3 on the y-axis, and then we went down to left 1. Our second line was the red one. It was started at -6, and it went up 1, left 1. So that's our two lines. And we'll go ahead and check our answer. Excellent. So that's how you would put in your two lines. And again, our solution that we found was -3, -3. So we found that there was a solution. And we're going to type in the ordered pair. So notice that we have an ordered pair button, so we're going to use that. And we have -3. And I'm going to plug in -3, because that was the point where they cross. And check our answer. Good job. So that's graphing a system of equation using graphing, or sorry, solving a system of equation using graphing. And then I also showed you elimination and substitution. Hope that was helpful.